Hello, welcome back to our next video here for our practice problems chapter 8. Continuing on, we're going to go to number 14 here, where we're given a p-value, or we're trying to determine the p-value and the significance of this test using an alpha level of 0.05. So here we're giving a z right-tailed test. So if you know right-tailed, so it's our null hypothesis is one direction, a z value here of 0.52. So if you have a z equals 0.52, then we're going to go look at our table, and z of 0.52 gives us a probability of 0.6985. And since it's a right-tailed test, we want to find the greater than. So in order to find greater than, we have to take 1 minus that value, and then that's going to equal 0.3015. So if you have a p-value of 0.3, that's a very high p-value. It's way bigger than our alpha level, so we automatically know we're going to fail to reject an hypothesis. So we can take C and B out of this equation. Now, when we're looking at it here, we're going to see D 0.3015, which is what we got as our p-value, and we failed to reject null hypothesis. So it is D A. If you had a p-value of 0.675, that is fine because you would, but for this particular problem, our actual p-value here is 0.3015. Number 15, moving on, is we have a claim that the majority of adults are in favor of a national healthcare system. What type of hypothesis is this? Is it left-tailed, right-tailed, or two-tailed? So the key words here is we have in favor of. Most of the time when you're in favor of and you're trying to test, a difference, that's kind of going to be like the majority of positive value. So you want to see that more people are in fact engaged into it, and that is going to be a right-tailed test. Left-tailed test would be something like the not in favor of, less than, all those words that are going to kind of point you to just the left-tailed version of the test, that they're less than the majority of people want it. You want to lose weight or something around those lines. And two-tailed is going to state something along the lines of you just want to test the claim, but you're not really sure if it's going to be higher or lower. There's no kind of words to give you a direction, so that would be a two-tailed. But in favor of is kind of more of a positive word, and that's going to lead us to a right-tailed answer. Here we go for number 16. For this one, we're just going to be writing out our null and alternative hypothesis for these parts. And we're given that they have to weigh precisely 19 pounds. And then our alternative hypothesis is going to state that either they're not 19 pounds. But it doesn't state if they're going to be greater than or not equal to, because they're going to be just right there. So our null is going to be of mu equaling 19, and our alternative is going to state that mu doesn't equal 19, right? Because it doesn't give us a direction. Some parts might weigh more, some parts might weigh less, and that's where we're going with it. Number 17, here we're given a paragraph talking about HIV meds, specifically increasing their CD4 count. So the hard part with some of these questions is that we're given a lot of information. When we actually do research, we don't know the conclusion of it, but in these kind of practice problems, we have to have kind of a conclusion already given us here. So after reading the problem, our test hypothesis, if you want to think about it, is to increase above the goal of 275. So our goal is to be over 275. So that means our null has to be 275 because that's what we're trying to be greater than it. So our null hypothesis is going to be mu is equal to 275, if we want to say cells per cubic millimeter of blood, and that our alternative HA is going to be mu is going to be greater than 275, right? We want to increase their CD4 count, not decrease it. So we want to be greater than that. And other things to take in consideration when you're reading these problems. If starting here at the sentence, in order to investigate a new drug, the researcher gathers a group of 48 individuals with their mean CD4 count of 317. If you see a group or a sample or something along those lines, we're gathering people and we're getting a sample average. So a sample average is going to be your X bar. So if you have 48 individuals and their mean is 317, that is their sample, so that's X bar, that's the average. Whereas, once again, mu is going to be our test hypothesis, what we're testing against, and that's going to be 275, and that's what's going to be used in our null and alternative hypothesis. Remember, it's going to be the same number in each. When we write out our z-test, we're going to say 317 minus 275 all over the standard error of n, which is the standard deviation over the square root of n, which I'm just going to write that out for you. It's 3.5507. When you take this value, we're going to get 11.8286, and that's going to equal our z value here. That's an equal sign, not another z. Equals z. So remember, if we were to look this up in the table, 11 is really big, and our table's not going to go that high, so we know that that's going to give us a 0.9999. Truly, it's even going to go further than that, but for the purposes of the table and how we're learning, we know that that's going to be cumulative probability from that value to the left. Since we're going greater than, we're going to take 1 minus that value, and that's going to equal 0.0001. We even know that's going to be less than that, so we could say our p-value here is going to be less than 0.0001. And then from that, we're going to say that our p compared to our alpha level, we're going to reject the null hypothesis. The null. Number 18 is one that you don't need to do. I have it here, but as this book has changed going through the years, I'm not going to have you actually calculate this particular problem, so you don't need to know number 18. Moving on to number 19 here, same thing, we're given a problem, and we're given a bunch of information. Once again, things to look out for is if you have an SRS, which remember from the way beginning of the year is a simple random sample of 124 individuals, sample average or their mean score on the GDS or GAG depression scale here as 7.5. So we already know our X bar is going to equal 7.5. And then when we know there's a population standard deviation of 0.4, make sure you just take in consideration it says 0.4 after consistent sun exposure, and that the clinical diagnosis for depression is a GDS score of 9. So we know that that is going to be mu is going to equal 9 here. So kind of going through this, we don't want to ever increase depression, right? We want to always decrease depression. So we're going to set up our hypothesis to state our null is mu is going to equal 9, because that is the clinical depression. And an alternative hypothesis is we're going to want to decrease depression, so mu is going to be less than 9. When we set up our test here, we're going to take 7.5 minus 9 all over 0.4 over the square root of 125, and that's going to give us a value of negative 41.7827. Now remember, this value right here is only 1.5 difference on the scale, right, on the GDS scale, which might not seem like a lot, but taking in what the standard deviation is and how many people we have, even small differences, with enough people will show a really big change. In fact, a negative 41, that's really big, that's really far apart. And since we're doing a less than, we know that our p-value is then going to be 0.0001 or even less than that, because our book only goes to negative 3.5. So we go here, we can write out our z-test, or our statistical test is going to equal negative 41.7827, and our p-value is going to equal, less than 0.0001. When we keep going, are we going to reject or fail to reject the hypothesis? Well, if we have an alpha level of 0.05 and we have a very small p-value, we're going to reject the null hypothesis. And what we're also stating is that, if you increase sun exposure, you'll probably decrease depression. And you kind of know this, is if you don't have a lot of sun, you're more likely to become depressed. Moving on to number 20 here. So hopefully you read this about the HPV, and we want to use a one sample z-test with significance alpha level of 0.05. Once again, I didn't give you a whole lot of space to work with here, but let's write out what we do have on the side, especially since there's a lot of text here. So we have a sample of 56. When we see we have a sample, we know that's going to be our X bar. And so our X bar here It's going to come from our sample. It's going to be 14.6. Our mu is going to be the population, or the average age here, first intercourse. And our standard deviation is going to equal 1.2. So what we're trying to do here is to see if the HPV vaccine increases females from engaging in early onset, engaging in sex earlier on than they would if they didn't get the HPV vaccination. So we're going to have our null be set up as mu is equal to 16.7, and all our alternative is mu is going to be less than 16.7 because that's what they're trying to test here. And so when we set this up, it's going to be 14.6 minus 16.7 divided by 1.2 over the square root of n, which is 56. And here we're going to get our z value of negative 13.0922. Once again, anything really kind of getting around, 1.92, a little over 2 is going to really show us significance in most tests here. That's going to be very low since we're doing less than our, and it's going to be less than negative 3.5. Our p-value is going to be less than 0.0001, and therefore we're going to reject the null hypothesis, stating that there is not a difference in onset of first intercourse if you get the vaccine versus not getting the vaccine. Reject the null. All right, and then our very last question, let me see how much time I have left here, just a couple minutes, so we're going to run through this. It's just walking through the steps one more time for writing out our null alternative hypothesis, where we have a teacher who's looking at attitudes towards testing based on your grade level. And so we're going to state the null is going to be that the average is 115, and our teacher, our professor, whoever is doing the study here, is saying that the average is going to be greater if you are an older student. We're going to then calculate a z-score given how many students she collected and then their mean. When we perform that, it's going to be 135.2 minus 115 all over 30 divided by the square root of 20. So it's going to give you a value of 3.0112. Remember, that's going to be our z value. Since we're looking for a greater than, we're going to find a value of this probability in the back is going to be 0.9987. Now we can turn that into a p-value, which is what we're doing in part C here, turn this into a p-value. Since we want to take that value and be greater than it, we're going to take 1 minus 0.9987, which equals 0.0013, and that's what we state our p-value at. And is there sufficient evidence? Well, our p-value is less than the alpha, which state right here, right in front of me, wow. Right here, so our p-value is less than alpha, so we would state that there is sufficient evidence to warrant rejection of the claim, regardless of age, the student motivation is the same. So she's saying that if you are an old student, that your attitude towards it does increase the test scores, and that's what she's proving here. And that is basically all what we were learning, broken down into just kind of step-by-step here in each one. As always, if you have any questions, always feel free to reach out to me and ask. If not, I will see you in the next video. Have a good day.